All right, guys, so let's get back to it. All right. So what we are going to talk about now is how to create a table, because that is going to be kind of one of the basic essential parts of the database, and how we store data in our database is like putting data into the table. So if you remember from our discussion before, some of these symbols here, like the curly brace and the bracket and whatnot, of what these things mean. So the things that are required are going to be the table name. So we'll do create table and a table name, and then column names along with a data type. Okay, now we can have as many columns as we want. Right? Column name, data type. We can have it be not null. Right? By default, if we don't include that, then it will be nullable. Okay, we can optionally also say it's going to have a unique constraint on it, on that column. Okay, some of these other things we'll talk about in just a moment. Let's get there. Okay, so it creates table with the one or more columns specified. Not null means that we cannot have a null value in that column, in any row in that column. We can specify a default value for the column if we don't want to allow nulls. Primary, or even if we, yeah, that's right, if we don't want to allow nulls. Primary keys, we'll have to specify them as not null to make sure that we know that those are not nullable. And a foreign key clause at the end, towards the end, we'll specify a foreign key. All right. These are domains. Again, MySQL doesn't allow for that, but we can have check constraints in a MySQL database table. All right, so here would be an example. Now, these things, pnumber, prooms, prent, were all defined as domains over here. Again, so basically just take what was here and replace it here. So pnumber varchar 5, we would say, okay, property number is a varchar 5, not null. Rooms is whatever data type it was. I think it's a number. Yep, small int between 1 and 15. Default of 4. Rent, default of 600. Owner number is who is the owner. Staff number, staff. All right, and branch number. So this is the property that's being managed by which staff, is owned by which owner that we're storing in the owner table, right? And which branch is overseeing it. All right, so notice that staff, right? Staff number, we don't have a not null constraint. What does that mean? We don't have a not null constraint on the staff number. What does that mean? So if the staff number is null, what does that mean? If the staff number were null, what would that represent? What do you think? Right, it means that so if the staff number is null in a row, then that means that particular property doesn't have anyone managing it at the time, right? And so, oh, what just happened? Did I accidentally use? So other things like branch number must be not null, because if a staff is not managing it, we still want to know what branch is overseeing it at the very least. That can be very important for later when we, as we talked about in the last discussion, we were talking about the referential integrity cascade on cascade, delete, set null. that one option would be that if a if a staff person got removed from our database because maybe they quit or fired or whatever, and we remove them, we want to set null their properties because we still want to have the property in the system, right? We still want to have the properties in the system, but we don't want them to have someone managing them since that person doesn't exist. So we would have the branch number still there so that we know which branch is overseeing it, so we would know which employees are options to make them the new managers for that. Okay. We express a primary key as property number, right? Meaning the property number will be the unique column that identifies every row. Okay, property number is kind of like your student number. We also have a foreign key constraint for staff number. Notice this ... means there's more to it. We would do more. So for example, staff number would have a foreign key to the staff table. Branch number would have a foreign key to the branch table. Probably we have an owner number as a foreign key to the owner table where we store information about our owners in the system. Okay. Now, once we've created a table, what if we want to change it? What if we want to add a new column or get rid of a column, or we want to add a new constraint or get rid of a constraint, or we want to set a default for a column value? We can do that, right? Because not everything stays like it was originally designed, right? There are things that we need to add to new information, right? So especially that adding new columns or getting rid of columns that no longer serve a purpose. So here, if we want to drop a default from the position column, okay, we can also alter the table staff to alter the sex column to set a default. What default of females? Does that really? Is that right? Do you think there's more female staff than male staff? Yeah, that's probably because in any animal population, there must be more females than males in order for that population to survive. So it's more likely that a person will be female than male. So that may be why they set that default there that way. Let's see. Okay, we can drop a constraint. All right, now notice that we're altering the table. Which table are we doing? And then what are we doing to that table? So we're adding a table client. We're adding a column for the preferred number of rooms. All right. Okay. We can drop a table, which would get rid of all of the table, which would get rid of the table and all of the data. All right. So drop table and then whatever the table name is. Views are basically dynamic tables in a sense that they are queries that we run frequently, and so we store them as a view so that we don't have to rewrite them over and over again. So basically the way that we do a view is we write a SQL query and then we wrap it inside of a create view statement. Okay, so we can create a view with a particular view name. Optional list of column names. If we include a column name list here, we must have a column for every column in the subselect and the select here. Okay. All right, so it must have the same number of items as the columns produced. Okay. If we don't have a column list here, then each column takes whatever name of the corresponding column comes here. Okay. All right. If there's any ambiguity in the column name, if we don't, like if two columns have the same name, we must give a column list to tell what the difference is between them. Okay. The select, we will call that the defining query. So it's the query that controls what the view is. All right. We also, in order to have select privilege on a view, we must have select privilege on all tables in the view. So here might be an example where we might say, okay, we're going to create we call it a horizontal view, meaning we're only going to have a subselect that includes a limited number of rows. So we're going to take all of the rows and we're going to say, okay, we're only going to look at some of them. Okay, so this might be the manager for branch 3, the staff table. So we are going to allow the manager at branch 3 to view the staff from branch 3. Okay, so we don't give this view access to all the rows in the staff table. We're only giving them access to the information stored in the staff table for branch 3. Okay, so this will look like a table and basically have the same columns as the staff table. So it has all the same columns as the staff table, including the branch number. Notice that all branch numbers are B003. So when the manager at branch B003, so I guess Susan here, when Susan tries to access the manager 3 staff, right, she will use it as select whatever from manager 3 staff view. It looks just like a table. Okay. All right. We could say, okay, we only want certain columns from the staff table. Right. So we can create a view of certain columns. Notice some of the things we're leaving out: salary, birth date, things like that. Right. Is position included? I know salary and birth date were not included. Position is included. Okay, so staff people at branch 3 can see other information about other staff people at branch 3, but they can't see things like what's their salary. Okay, which is very common in business, is to not allow you to see other people's salary. Okay. All right, we can use a group by to be able to get things like what's the number of properties that people are currently overseeing, right? And use that as a view. Remember yesterday we gave this as an example of a table where we could insert into the table all these values, right? This brings up an interesting question about trade-offs, right? So which is better, to use a view or to use a standalone table with an insert that inserts all these, right? So do you guys remember that when we had the staff prop count table and we inserted into that table all of these values? I hope you remember that, since it was just yesterday that we did it. And here's an example where we could do it as a view instead of as a table with an insert. Which one of these is better? Why did we show you both ways? Like, which one of these is better? Of course it depends, Arjun and Doan. Quick on the trigger there, quick on the draw. All right, so let's talk a bit about that, okay? And actually what I'm thinking we will do here, talk about dropping views, and then I'll skip over and do some examples, and then we can end our class time there. And then, because I really want to show you some examples of these things, but let's talk about the differences here between the view-based approach or the table-based approach. Okay, so let's see. Let's list out some pros and cons. All right, so option 1 that we talked about yesterday was a table, and then we insert into the table from the source, from the other things, right? Okay. 2 is we create a view. Okay. All right. All right, so what are some of the distinctions here? Okay, let's see. If we create a table, and we insert into it from the source, right, then when we go to select from the new table we just created, the data is there. It's automatically there. There's no need to do any calculation, right? It's very fast, right? Select is fast here because the data is just there. The data is there in the table. So when we select that information, we get it immediately. I mean, not absolutely immediately, but you get the idea because the data is already there. There's no calculation. There's no group by. There's none of that. OK, select. So selecting from the view, select is slower, has to calculate. Right, has to calculate what's the count of all that. All right. Okay, so seems like, okay, score 1 for the table approach. Okay. Think of a problem with the table approach, because, you know, in all these things, always why it depends is because one has a good thing and one has a bad thing, but there's always you always have to pay. There's the Tan-Staffel principle. If I've shared that with this class before, the Tan-Staffel principle. If you've ever heard of that, look it up if you haven't. Is that there's we don't get anything for free, right? So can you think of something of a reason why the table approach would be would have a deficiency, would have a problem that the view approach would be better? No one? I can't think of any reason. All right, well, let's consider this. Oh, somebody said something. More tables and data to manage. Yeah, right. So a big one of the big things here, one of the things, more tables, right? So more tables, more data, right? And redundant data at that, right? Because think about this information here where you have the branch number and the staff number, what branch they work at. That information is already stored in the staff table, right? And so there's really this becomes kind of a redundant situation. Okay, less actual data stored. Although the view does take up some space because the query does have to take up some space, but also more in backups. It all adds up. The backup because of more data, but also what about data? Not redundancy. I will say more data. I'll call this data redundancy. Consistency. We'll call it consistency. So what happens in the situation where data stallness? I don't know. I've never heard that word before. So what happened? What does this represent? This represents there's nowhere in the view approach. There's nowhere that these values for count are actually stored, right? 1 is not stored somewhere. 2 is not stored somewhere to represent this. What it represents is how many properties staff number SG37, how many times the SG37 staff number appears in the property for rent table, right? Because every time that the certain staff number appears in property for rent, that represents one property that they're overseeing. So if their number appears 3 times, 4 times, 5 times, they're managing 3, 4, 5 tables. Properties. All right. So what happens if SG37 gets added again, gets added to a new property? They're managing a new property in our property for rent table, right? Well, this number should change, right? From 2 to 3. Well, so what would happen is if we insert a new property, right, or delete an old property, or change the staff person who's overseeing a property, right? If we do that in the property for rent table, using the table approach, we've also got to change it in the staff prop count table, right? So now, when any change involving any change that would result in a change in the property in the staff prop count table would have to require a new would require us to execute a SQL statement, an update statement on the staff prop count table to keep data consistent, right? So to keep data consistent, inserting a new property requires an update on staff prop count. With the view approach, there is no data actually being stored for this information. It gets it directly from the source table, the staff table, the property table, right? So there's no I'll call it better data consistency, because it may not be perfect, but when the property is inserted, when a new property is inserted, automatically, right? When a new property is inserted, the view automatically gets that update, right? Because that view is dynamic, right? So basically, the it depends part here, the reason why you guys hear me say that all the time is the whole, like what I said, the Tan-Staffel principle, and maybe I'll share that Venn diagram that I may have shared with you once before about how things work in system development, right? Is that if you have a situation where you need the data quickly when you're trying to get that information and it doesn't change frequently. Right? If you need the data quickly and it doesn't change frequently, a table-based approach might be what you want. Okay, might. Okay, not saying it is, it just might. Okay, if getting the data as part of a select, as part of a data access, if it can be a little bit slower, now I'm not talking about it won't be minutes slower, right? But if it can be a little bit slower, but the data, the base data that powers that view, that powers that calculation, changes relatively frequently, then you want to use a view. Okay. All right. So like I said, let's just finish up one more thing about views. The way to drop a view is the same way as dropping a table. You simply say drop view manager 3 staff like this, and this will get rid of the manager 3 staff view. Okay. We can also cascade that any dependent objects will be deleted, right? And then restrict could be if any other objects depend on their existence for the continued existence of this view, right? Then we won't be able to allow that. Okay. Discard that. let's see. Let me put this into the chat so you guys all have access to it. All right. So let's talk. Yeah. All right, so let's talk SQL on this. All right. So a couple of things. One example that I found online was about this persons thing. Let me drop that actually. Okay, so I have the persons table, but I want to create it. Let's see. So I want to show how we can create a table. So let me first get rid of this table. Okay, so I'm going to drop the persons table. Click, where's my go? There's go. Oh, forgot drop table persons. By the way, one thing I had said before, okay, you can type it like this. You can type it like this. Both of these will do the same thing. SQL is what we call case insensitive, right? Meaning that it doesn't matter, uppercase, lowercase, doesn't matter. I would say this one is considered better for reading purposes, that the SQL keywords being in all caps, other things like table names and column names being lowercase, is considered more readable. Standard is considered standard. Okay, so let's run this. Yeah, do I really want to do that? The reason why it's saying that is because it's going to get rid of my data. All right, so, all right, let me do this. Let me create a table called persons. Okay, so how do we do that? How to create a table? How do we create a table? No one? No one knows how to create a table? Yes, create table. Great. Okay, so create. Oh, look, there it is. Create table. Oh, there it is. Table. Great. Okay, so create table. Let's call it persons, or typically I suggest you table names should be singular, just like class names in Java. That's my take on it. Again, you're not required to make it that way. There's no requirement that it be that way, but that's just how I do it. Okay, create person. Okay, we want some columns, right? So let's see. Let's have each person has an ID, maybe. That could be a number, so an integer. Not null. Okay. Actually, again, not. What else? What do people have? Name. Oh, birthday. Let's hold off on birthday because we're gonna give them an age, and you'll see why. So let's see, a name could be a varchar, and this is where we might give a limit of how many characters it can be. So maybe 25. I know you probably don't have a lot of people who have names that are 25 characters long, but actually, like I said, the way it does it in the Turkish system is that we count middle names as part of first names. So like my youngest son, who actually has 2 middle names, I don't know why we did that. Actually, I do know why we did that, and it's a good reason. But he has 2 middle names, which means, you know, his first name in the Turkish system is very long. All right, so let's give a limit to 25. Surname, also varchar. 25 maybe. Let's give an age and make that an integer also. Well, we should actually have their name be not null. Their last name be not null. Okay. And age. All right. Should be good now when we run this. Okay. Now I'm going to show you something with MySQL. So if we show the query box, so remember this query. Okay. In fact, what I'll probably, let me do this. Let me go over to here so that we can see it later. Let's do this. I'm going to create, this is 4 columns, so that should work. Okay. I'm going to create a new table. So it's going to give me it defaults to 4 columns. If I want to do more than 4, what we could do is we could go back to the main page and you can say, create a new table, how many columns, right? So it was for, the table name was person, right? I can't do it again because it's probably going to give me a, hey, that table already exists, right? That table already exists. So let's do person 2 and I'll show you why. Okay, person 2 with all the same information. So ID, that was an int. Name, that was a varchar 25. Surname, that was a varchar 25. And then finally age, that was an int, right? So if I can preview the SQL here, notice that I can't move it. It looks very similar here, right? ID int not null, name varchar 25 not null, surname varchar 25 not null, age int. One thing that it did differently here was it made it not null. Let's change that. Null right here. So allow age to be null. Okay. All right. So now preview SQL and notice that part changed. All right. So that is a way that you can use the user interface to do the work of creating this different information for this, for tables. And then you can do the preview SQL to get the SQL here, right? So I'm telling you this for those of you who are going to be doing the group project again this semester. By the way, I've already gotten a couple of emails about that, and I need to update the slides to show which project topics have already been requested. But one of the things you can do is you can use the user interface to try to create your table and then use the preview SQL for the purposes of taking that and putting that into your report. Okay, you know, if you want to, some people find it much faster to be able to write the SQL themselves, especially for some simple queries. It's definitely a lot easier to write the SQL yourselves. But I'm just letting you know that this is a way that you can kind of save yourself a little time and be able to have access to the SQL for the purposes of writing your report. Okay. All right. So we won't actually create this table because I want to go show, okay, we're going to insert into our person table. Okay. So here we see, yeah. So let's see, structure. I can see all the different options here. Okay, because what I want to do is I want to show a way to do a check constraint. Okay, so let me insert into here ID, just make something up, 1, 2, 3, name, okay. Age, let's just leave that blank. Okay, 4, 5, 6, and my wife's name, the day. Well, we gotta have somebody have an age, so let's just give her 25. Yeah, we'll go with that. Okay, just like before, when we go to click go, okay, it's going to insert the 2 rows. Notice it shows us what the SQL would have been, right? Okay, now we can also do this. Oh, one thing that I forgot to do is I wanted to make this the primary key. The ID should be the primary key. Okay. Now, what that means is all of the here IDs will need to be distinct. So if I try to insert 1, 2, 3 again, but this time with my son, my oldest son, with his information, age 13, right? It's going to tell me, nope, can't do that. Duplicate entry for the primary key. All right, so I can give him a new primary key. Let's make it 124. Okay, and that should work fine. All right. Okay. Again, we can take the insert statement. We can say 125, Grace, and she is 10. Right, and we can do this as many times as we want. 126. John. And he is 8. Okay, and I'm going to add my mom in here too for fun. Okay. Actually, I'm going to add my older sister. How old is she? Okay. I need to add one more person that's above 21 for our next example. Okay, 129. And let's make them 26. Okay. All right, that should work. Okay, yep, good. So now if we go and we say, okay, I want to see all of the results from person, right? All right, so this is all of my results. Oh, no age there. Perfect. All right. Now, if I want to, I can, let's say, create a table. Okay. And an old person is defined as someone older than, what's the oldest person in this chat student-wise? Let's see. Let's say an old person is anybody older than 23. Okay. All right, so I want to have all the same information in the person table. So an ID, which is an int. Right, not null primary key. Okay. I want to have them having a name, which is a var char 25, not null. I want to have them have a surname. bar 5 not null. And I want them to have an age. Int. Okay. Probably needs to be not null here, but that's okay. We don't actually have to have that. And then we need to give it a check constraint, right? So let's see. I did this before. So we want to have a check. Age is greater than 23. Does that kind of cover everything? It looks like it. Okay. All right, so now we have an old person table. But if we look at the browser, there's no data in it. Right? We don't have any data. We didn't put any data in here yet, right? So we can either insert, right, new data. So let's see. Let's give it a completely new number because I don't want it to have any problems with name. My mom. Her age. Don't forget how old your mom is. I think that's right. I'd have to do the math. All right, so we can insert using the values keyword, but remember we can also insert how? We can insert from other tables, right? So I could insert, I could say, okay, insert into select, select all of these things, right? From person. All right. So if I run this, we'll get all of the information from person put into our old person table, right? Oh. Wait, what? What happened? Why did this give me an error? Right, the check condition. Why? Because there are people in my person table. I'm going to copy this because we're going to fix it later. Okay, if I go into my person table and look here, right, there are values that don't fit my old person table, right? Okay, so let's do this. Let's do. We're going to do this. We're going to say where. One thing I do want to show you first before we go into that is if I go to the old person table, notice that there's still only one person in there, right? Even if one row fails to insert, even if only one row fails to insert, it will reject the entire insert. So even though, if we go back to person, right? Even though 1, 2, 3 rows should have gone in, right? 3 rows satisfied the condition, right? Even though only one row failed, right? It rejected the entire insert. Okay, it'll do that with updates. It'll do that with deletes. If even one part of it fails, it'll reject the entire, what we call a transaction. So that insert was considered a transaction. And because one part of it failed, the entire thing did. Okay, so let's do this. Let's insert into from person, but only give me the ages that are greater than, let's say greater than 40. Okay, so now what we should see, if we run this, okay, it inserted one row. There's only one person older than 40? This one right here, right? So K, my older sister, should now be in the old person table, right? All right. Okay. All right. So let's see. One more thing. Let's see a couple of things. Select from person where. By the way, one thing I suggest you do is formatting your SQL. The way I like to format it is if I were to type this from scratch, type this from the beginning, is I would position my from here and my where here. And the reason why is because then all this lines up vertically. Okay. So let me select from person where age is greater than 23. Okay, so these are all the people. Right, that's what I'm getting at. Yeah, perfect. I'm getting all the people that are older than 23. All right, so that's these, right? So these are all the people that would be able to be added to the old person table if I wanted to. Well, let's do that. Let's insert them. Select star from person. All right. What? Oh, my older sister was already there. Oh, okay, so we could say and ID not equal to 128. Yay! It inserted into my old person table, right? Yeah. Okay. Now what William was talking about there was that's not what I meant to do. Where age is greater than 23. Okay. So I should get those 3 rows, right? Okay. Now what about where age is less than 23? Okay, that makes sense. Well, but there is one person missing, right? So that must be, if it's not greater than 23 and it's not less than 23, it must be equal to 23, right? No rows, but there's, okay, wait a second. There's a person missing, right? Who's missing? Do you guys notice who was missing? I hope somebody noticed who was missing. There was one person missing. Who did not show up in my result set? These 3 showed up. These 3 showed up. I didn't show up. But I did greater than 23. I did less than 23. I did equal to 23. And I never showed up. Oh, right. Because it's the null value, right? So, okay, that's easy to fix. Okay, so I want to see where age equals. No. Right. This will get me, right? Empty. Okay, I'm getting really confused. So where age equals null, where age not equal to null. No. Oh, that's right. We talked about that, didn't we? Where age is null. Right. So if I wanted to see, there I am. Finally. right? Okay. What do you mean a way to get the written queries before? What do you mean by that? Like the ones that I'm writing here, like can I provide them like in a text document or something before the class? I can work on that. I can work on that. One thing I do want to go ahead and say is, okay, so we showed a way to do the old person thing as a table, but what if we wanted to not do it as a table, we wanted to do it as a dynamic query? So we could say create view old person view as select star from person where age is greater than 23. Okay. So here, this is the subselect. This is the view name, right? So if we were to say, okay, so now we have a view called old person view. So if we were to say select star from old person, period, that's it, right? We would see this information here. We forgot to add somebody, didn't we? But old person view, we would see these. Who do we have? Oh, we added somebody to the old person. Right, we added this person. We added my mom, right? No, my mom. Who did we add? We added my mom. That's right, we added my mom. So notice though the same thing we did here, right? To view the information in old person, it works just like a table. Select star from old person view. Right? Notice my mom's not there because we added her to the old person table before we created it. Right? So if this table was supposed to represent a dynamic view of the person table, where only older people were included, right? Then we could delete a row from it, right? We would delete this row. Right. Now, remember I told you we can write a SQL query to delete something, and this will be the last thing I have to have time for today, right? If we delete, right, do you really want to execute delete from old person where old person ID equals 789? Okay, MySQL is going to show you the delete, and it's going to delete based upon the primary key value. Okay, so because old person ID is 789, it deletes based on the primary key value, not on anything else. If what you wanted was to delete based upon something like a name, we could write that. We could say delete from old person where name equals, right? And this would do the same thing in this particular situation, right? If you really want to delete from old person, yep, taking that out. So now if we look at the table now, it's gone. Okay, so again, you can just click delete and it deletes this, and it can show you the SQL that you could use to do it. You can also delete multiple rows, right? Do we want to really execute this where it would execute 3 delete statements, right? Alternatively, we deleted all the rows, right? So we actually don't have to run 3 delete statements, do we? Right? We could just say delete from old person, period. Where if we delete this, there we go, really want to delete, yep. Notice we go and look at it, there's no data there. No data, but the table is still there. If we want to remove the table, we drop table. Do you really want to do that? Yep. And now that table is no longer there. Okay. All right. So I ran a little bit over. So we'll end there for today. We still have some slides on data definition language of SQL that we need to finish next week, but we'll do that on Wednesday afternoon. Okay. Are there any questions or comments before I dismiss? Right. Yes. What William is suggesting, kind of running select star before you do almost anything is probably a good idea. Especially if you're dropping deleting or updating or inserting based upon a condition, to make sure that what you are doing is actually what you want to do. Select doesn't change anything in the database. So we can select all day long and we can see what we're doing before we actually delete, update, or insert. So running, that's one of the reasons why I said what you'll start to be able to do in your sleep is type out select star from table, right? You'll be able to start doing that where you just be able to do that in your sleep, right? Where select star or let's call it person, or select count star, right? Because while running the select count star, like sometimes we can say, okay, 7, okay, that's what I expected to see. Or select count star from person where age is greater than 23. And if you are expecting it to be something like 5 or 6 and you see 3 instead, you're like, well, something's wrong here, right? So selecting before you do something like a delete or an update or an insert can definitely help with knowing that you're doing the right thing, what you expect. Okay. If we use primary key for a field, not null, I think it probably would require it. I don't know what would happen if you didn't do that. That's a good question. Let me look at it since we're over time. Let me look at it, and that'll be something we can talk about first thing Wednesday, or I can message it in the team. Okay. All right. Good question, Umut. I'll look into it because I don't think I've ever done that. All right. No other questions, comments? We'll end there for today. Thank you guys for joining. I'll see you on Wednesday.